Alright, this is lesson 4.2, still in stretching and shrinking. We are talking about ratios inside of triangles now. Lesson 4.1, we looked at ratios more in rectangles and parallelograms. This time we're going to compare or apply exactly what we just learned inside of triangles. So we're going to compare similar shapes using ratios. We're going to turn fractions into decimals to compare the ratios of triangles. The only difference from 4.1 to 4.2 is the kind of shape. So let's go ahead and start it up. Alright. Point blank, here's 4 triangles. Which triangles are similar? How do you know? Now, first thing we want to look at is the same thing we did with parallelograms. Are the angles equal? Now in a triangle you have to worry about all 3 angles. What you should remember in triangles is that the angles inside a triangle add up to 180 degrees, because we need to be able to find that odd one out. Each triangle we have a missing angle. So triangle A, 45 plus 35 is 80 degrees. So what's left out of 180 is 100. 42 and 58 equals 100. What's left is 80. 145 equals 145. Well, we know if we have 145, 35 is what's left. Once again, we have 100, we have 45, so 35 is what's left. Now, 100, 45, 35, 100, 45, 35, 100, 45, 35, 42, 58, 80. That one we know is out. Saved us some work by not having to do a third or a fourth ratio. Now what we need to do is compare ratios of the remaining ones. So triangle A, I'm going to put the long side on top, short side on bottom. C, long side on top, short side on bottom. And D, long side on top, short side on bottom. And I'm going to go ahead and use a calculator because these decimals are pretty mean. So, first one, 12.5 divided by 7.3 equals 1.71239. Like I said, not a very nice decimal. The calculator is even rounding it. Next one, 18.8 divided by 11. Oops. 18.8 divided by 11. 1.709091. That's nasty too. Last one, 31.3 divided by 18.3. 1.710383. Now, these are all 3 pretty nasty decimals, and they're also not all the same. However, if we were to round, then they're close enough to the same. 1.71239 rounds to 1.71. 1.709091 rounds to 1.71. 1.710383 rounds to 1.71. All those decimals are the same, so therefore triangle A, C, and D are similar. Which answers number A? A, C, and D are similar because their angles and ratios are equal. Because their angles and ratios are equal. Don't forget you have to do both unless it's a rectangle. Let's apply it to another group. Sorry, apparently I just did part B as well. That should be included as well. That's where your work should go. My mistake. Let's move on to our next group of triangles. So, use ratios to find which triangles below are similar. Circle the pairs of similar triangles and cross out the triangles that are not similar. So we have 5 triangles, same exact thing we just did. First, let's worry about the angles. 25 and 136. Actually, let me help you speed this up a little bit and show you how to do this a little bit quicker. Close my calculator on accident. So 25 and 136 is 161. What's left out of 180 is 19. I'm not going to spend much time on those calculations since those should be easy. 25, 19. Well, we have 25, 19, 136, so 136. 94, 30. 94 plus 30. What's left out of 180 equals 56. 56, 94, 56, 94, so 30. 120, 44. I'm messing this up. Plus 4 equals 164 minus 180. What's left is 16. Alright, let's take a look at our angles. 2019 136, 2019 136, those have potential. 3094 56, 3094 56, those two have potential. 120 44 16 can't be similar to anything. So let's focus on the ones that can. Triangle A, long side over short side. Triangle B, long side over short side. Triangle C, long side over short side. Triangle D, long side over short side. Use a calculator, turn these fractions into decimals. 6.5 divided by 3 equals 2.2. I'm going to round that. 3.25 divided by 1.5, 2.2. 6 divided by 3 is 2. 3 divided by 1.5 is 2. So what it looks like is A and B are similar and D and C are similar because the angles are equal and the ratios are equal. I didn't even have to do triangle E because I found out it was not similar to anything because of its angles. Alright, let's check back through the worksheet. Lesson 4.2, ratios inside triangles. Learned how to compare similar shapes using ratios. We turned fractions into decimals to compare the ratios of triangles. We looked at these 4 triangles, figured out their angles, figured out which one does not fit, calculated the other ratios, turned them into decimals, rounded the decimals, figured out the A, C, and D are similar. We did the same thing here. We looked at our 5 triangles, figured out the one that did not fit entirely because of its angles, and then turned the other 4 into ratios, turned those ratios into decimals, and matched up the ones that went together. This is the end of lesson 4.2. Up next is lesson 4.3, still in stretching and shrinking.